For decades, the T-series of main battle tanks stood as the ultimate symbol of Soviet and later Russian military strength. These low-silhouette machines embodied the idea of mechanized decisive power, a vast steel force designed to sweep across the plains of Europe. The image of the compact, mass-produced T-series tank became synonymous with Moscow's ability to project force on land. Yet, 2 years into Russia's full-scale invasion of Ukraine, that image has been shattered into thousands of burning wrecks scattered across the steppes. What we are witnessing is not just a run of bad luck, nor a minor tactical misstep, but a historic disaster. The scale of Russia's armored losses raises a stark question. Are Russian tanks reaching the end of the road as a decisive weapon? The collapse of Russian armor in Ukraine is not primarily the result of isolated blunders, poorly trained crews, or occasional command errors. It is the product of something much deeper. The entire operational concept behind Russian tanks has become catastrophically obsolete. This terminal failure is driven by a collision of three overwhelming forces: a fatal design flaw embedded in every Soviet-era hull, the emergence of a technologically superior and asymmetric kill chain, and a grinding war of attrition in which Russia's industrial base cannot replace tanks at anything close to the rate at which they are destroyed at the front. The war in Ukraine has turned into a live laboratory for modern warfare, where cheap, widespread technology consistently defeats heavy armored platforms. What was once a decisive weapon has been transformed into a high-value, relatively easy-to-destroy target. From the earliest weeks of the invasion, the world watched constant footage of Russian tanks with their turrets blown off, a gruesome signature of a fundamental vulnerability baked into their design. The deepest weakness of Russian armor lies in the underlying philosophy that has guided its engineering for decades. Generations of Soviet and Russian tank design have been built around a structural compromise that seemed acceptable during the Cold War, but is now fatal. This is not just a problem of maintenance, crew training, or battlefield tactics. It is, above all, a doctrinal failure that chose low profile and mass production over crew protection, survivability, and repairability. When the T-72 was introduced in the 1970s, Soviet engineers set out to build a tank that was smaller, lighter, and easier to conceal than its NATO rivals. This approach was rooted in post-World War II doctrine under leaders like Khrushchev and Brezhnev, which envisioned a massive mechanized thrust into Europe, relying on overwhelming numerical superiority. It was a deeply philosophical choice. Western militaries invested heavily in keeping their highly trained crews alive in long, grinding campaigns, while Soviet doctrine treated tanks as expendable assets that could be sacrificed and rapidly replaced. This trade-off produced a tangible metric advantage. The T-72's hull-down profile and overall height of about 2.19 meters was significantly lower than that of the M1 Abrams at roughly 2.39 meters, or the German Leopard 2 at around 2.48 meters. A small silhouette was treated as a critical asset for defensive positions and for avoiding detection in a large-scale European conflict. However, the compact dimensions of T-series tanks came at a serious cost. Their interiors are notoriously cramped, increasing crew fatigue and making combat operations more difficult than inside the larger, more ergonomic fighting compartments of NATO tanks. To cope with the limited internal volume while keeping weight and cost down, Soviet designers adopted an automatic loading system. By replacing the human loader with a mechanical autoloader, they reduced the crew to 3 people and lowered the overall volume of the fighting compartment, allowing for a smaller hull and turret. That choice solved the size problem, but introduced a much greater one. The design of the autoloader forced a catastrophic compromise in the internal layout and crew safety. The ammunition storage system that feeds the main gun, a circular carousel containing dozens of high-explosive rounds and their propellant charges, was placed in a ring directly beneath the turret floor and the crew positions. This location, essential to keeping the silhouette low, turned the tank into a massive volatile bomb waiting for a small penetration to trigger it. The same basic architecture runs throughout Russia's deployable fleet. The T-64, the widely used T-80, and the current top-tier T-90 all share this vulnerability. Once an enemy round penetrates the relatively thin side, rear, or lower armor and hits the carousel, a rapid chain reaction unfolds inside the tank. One propellant charge ignites, then the rest follow in a fraction of a second. The result is a huge internal explosion that the crew has no chance to survive. Pressure in the sealed hull spikes instantly, and because the structure cannot contain it, the blast vents through the weakest point, the turret ring. That is what produces the infamous jack-in-the-box effect, where the turret, weighing around 12 tons, is ripped away from the hull and thrown into the air. This turret toss has become the visual hallmark of Russia's armored catastrophe, marking both the complete loss of the vehicle and the almost certain death of its 3-person crew. Modern NATO tank designs took almost the opposite doctrinal path, putting crew survivability at the center of their philosophy. Tanks, such as the Abrams and Leopard 2, store their main gun ammunition in an armored compartment in the turret bustle, at the rear of the turret. This ammunition bay is separated from the crew by an armored bulkhead and equipped with blowout panels, special weak sections that are designed to rupture outward if the ammunition detonates, directing the force of the explosion away from the crew instead of into the fighting compartment. This approach means that while an Abrams can still be disabled or knocked out, the crew often survives the loss of the vehicle. They can escape, and the tank itself may sometimes be recovered and repaired. The designers willingly accepted a slightly higher vehicle profile in exchange for a far greater chance of saving trained personnel and preserving valuable hardware. The doctrinal contrast is clear. A successful hit on a Russian tank is usually a catastrophic kill. A successful hit on an Abrams is often only a mobility kill, with the crew still alive. For Russia, this has two devastating consequences. First, the material loss is almost always total, adding up to a strategic drain on armored assets that cannot be reversed. Second, and even more damaging, each destroyed T-Series tank usually means the instant loss of a fully trained crew. Tanks can theoretically be replaced by older models. Experienced tankers cannot. The steady loss of this human capital accelerates the decline of Russia's ability to conduct complex combined arms operations. What might once have been a tolerable risk in a Cold War tank battle has now become fatal in the face of a modern, asymmetric kill chain. The battlefield has shifted away from heavy metal versus heavy metal toward a domain dominated by precision sensors, low-cost mass-produced systems, and pervasive electronic warfare. At the outset of the invasion, the influx of advanced Western anti-tank guided missiles, or ATGMs, gave Ukrainian forces an immediate, overwhelming edge. The American FGM-148 Javelin and the British-Swedish NLAW were especially destructive because they were designed to defeat exactly the kind of protection Soviet doctrine emphasized. The Javelin is particularly feared for its top-attack flight profile. Fired by a single soldier, the missile rises high into the air before diving down onto the tank's roof, where armor is at its weakest, often just a few inches of metal. This trajectory bypasses the heavily reinforced front glasses plate that Soviet designers relied on for survivability. On top of that, the Javelin's tandem charge warhead is built specifically to defeat modern explosive reactive armor, or ERA. Russian systems like Relikt and the newer Malachit on the T-90M were designed with sophisticated layered ERA blocks to counter advanced shaped charges. But the Javelin's first small charge is meant to set off the ERA tile, and the second main charge then strikes the exposed underlying armor, punching straight through. In practice, this has rendered Russia's pride in its ERA systems largely meaningless against high-end Western missiles. The psychological effect of these weapons is as powerful as their technical capabilities. The Javelin's fire-and-forget guidance uses an imaging infrared seeker that locks onto a tank's heat signature. After launch, the operator can immediately move or take cover, instead of having to guide the missile to impact. This dramatically increases the survival chances of the infantry, and it transforms every roadside, tree line, and urban corner into a potential ambush point. Russian armored columns suddenly faced a highly decentralized and lethal defensive network that they were unable to suppress or bypass. This is the essence of modern asymmetric warfare: small, flexible teams equipped with smart munitions that can reliably destroy much more expensive platforms. While ATGMs delivered the initial shock to Russia's tank forces, the ongoing day-to-day threat now comes from the mass deployment of first-person view, or FPV, kamikaze drones. These drones, often costing only a few $100s per unit, less than a single tank round, function in practice like miniature precision-guided anti-tank missiles. In Ukraine, they have created a persistent kill chain that operates 24 hours a day, 7 days a week. Their sheer numbers have turned the front line into a glass battlefield, with visibility extending 10 to 20 kilometers into the depth of enemy positions and robbing Russian armor of the to maneuver unseen. FPV drone operators do not always aim for a catastrophic kill. Frequently, they target key components such as tracks, engine covers, external fuel tanks, optics, or the main gun barrel. A mobility kill, disabling the tank's ability to move or fight effectively, is often enough. Once a Russian tank is immobilized, stuck in a trench, or attempting to dig in, it becomes a stationary high-value target. FPV drones can then return to finish it off, or artillery and other drones can be directed onto its coordinates. Reports indicate that Ukrainian forces are deploying tens of thousands of FPV drones each month, enabling increasingly sophisticated swarm tactics. Multiple drones can be launched in loosely coordinated waves to overwhelm a single tank and any supporting electronic warfare defenses around it. Some of the more advanced FPV designs are even integrating basic artificial intelligence and computer vision, enabling them to recognize and home in on targets even when GPS is jammed or communication links are disrupted. Loitering munitions add another layer of pressure. Russian-made systems like the Lancet are used to attack support vehicles, self-propelled artillery, and other critical logistics assets. Together with FPV drones, these weapons put constant stress on the entire support chain needed to keep tanks operating at the front. The result is not just the destruction of individual vehicles, but a systemic logistics crisis that undercuts the very concept of armored spearheads. The most damning verdict on Russian tank doctrine, however, is the near-total absence of integrated modern active protection systems on the vehicles that are actually fighting in Ukraine. While NATO tanks such as the Abrams and Leopard 2 are increasingly fielded with active protection systems like Israel's Trophy and related Western designs, Russian tanks still rely overwhelmingly on passive armor and ERA. Russia does possess indigenous APS technologies, including the Arena system and the more advanced Afghanit planned for the T-14 Armata. But these systems have not been rolled out across the workhorse fleets of T-72s, T-8050s, and T-9050s. The reasons are straightforward. The systems are expensive, difficult to integrate on large numbers of older vehicles, and Russia struggles to obtain the advanced electronic components they require due to sanctions. An active protection system uses radars, often in the millimeter wave band, to detect incoming projectiles such as ATGMS or rocket-propelled grenades. Once a threat is tracked, the system launches a small counter-munition to intercept and destroy or deflect the incoming round just before it reaches the tank. In an environment saturated with shape-charge warheads and top-attack munitions, such a system is the only truly reliable defensive layer. Without APS, Russian tanks are static targets in a battlefield dominated by smart weapons. Every successful hit on a passively protected T-series vehicle is likely to become a catastrophic kill, especially once the ammunition carousel is compromised. ERA systems like Contact 5 and Relict embody a defensive philosophy that belongs to a previous era. Explosive tiles that detonate outward when struck can be very effective against older anti-tank weapons and some kinetic projectiles, but tandem-charge warheads like Javelin and NLAW are explicitly designed to defeat them. ERA is also practically useless against FPV drones that drop or ram explosives onto the thinly armored roof of the tank or into exposed engine decks and optics. Russia's failure to adapt to this multi-vector threat environment, from the front, the sides, above, and at long range, exposes a deep dysfunction in its procurement and modernization system. This is not simply the result of sanctions. It reflects a more fundamental failure to understand how the battlefield has changed and where the true vulnerabilities lie. As a result, even those Russian tanks that receive sporadic upgrades are still fighting in a modern theater as essentially passive targets. Every improvement that does not include integrated sensors, active countermeasures, and networked situational awareness is merely an incremental patch on a fundamentally broken architecture. The continued reliance on ERA and bolt-on armor, without fully embracing active defenses and real-time sensor fusion, is the final strategic nail in the coffin of Russia's once-feared armored forces. Russia entered the invasion boasting about its powerful electronic warfare capabilities. Large systems such as the R330ZH Zaytel and LIR-3 were designed to jam communications and GPS over wide areas, theoretically shielding Russian units from precision strikes. In practice, these large EW platforms are bulky, vulnerable to artillery and drone attacks, and slow to reposition. Most importantly, they have failed to provide consistent, reliable protection for individual tanks and armored vehicles at the front. The sight of crude, improvised Tsar Mangal cages welded on top of Russian turrets is a stark admission of this failure. These makeshift grills were supposed to pre-detonate incoming drone warheads or disrupt top-attack missiles. Instead, they often add weight, reduce mobility, and strain already old transmissions, all while leaving the sides and rear of the vehicle exposed. In many cases, they do little to stop a skilled FPV pilot who can simply maneuver around them. The resort to such field-expedient fixes underscores the gap between the promises of Russia's military-industrial complex and the reality experienced by crews on the southern front and other critical sectors. Meanwhile, commercial drone technology continues to evolve rapidly and is adapted on the battlefield far faster than Russia's centralized bureaucratic counter-drone efforts can respond. The final factor that confirms the decline of Russian armor is the harsh economic and industrial reality. Russia is losing tanks faster than it can build or modernize them. Thanks to open-source intelligence efforts, the scale of this attrition is documented with unprecedented clarity. Organizations such as Oryx and the Conflict Intelligence Team, or CIT, have compiled visual confirmations of thousands of destroyed and captured Russian vehicles. Independent analysts estimate that Russia has lost more than 3,000 tanks, roughly equal to the entire active pre-war tank inventory of the Russian army. To keep its forces equipped, Moscow has had to fall back on Soviet-era stockpiles, stored at decaying reserve bases spread across the country. Tanks are being pulled out of long-term storage and sent to factories for refurbishment in a constant effort to replace losses. Satellite imagery shows rows of these storage yards steadily emptying as usable platforms are extracted. Russia is now forced to restore deeply outdated models, such as the first-generation T-62 and even the post-World War II T-55. On a modern battlefield saturated with ATGMs and FPV drones, these vehicles offer virtually no meaningful protection. The refurbishment process itself is riddled with compromises. Many of these resurrected T-62s and T-55s are returned to service without modern fire control systems, reliable digital communications, or thermal imaging optics. Their older engines and chassis, subjected to the additional strain of improvised armor plates or cages, are prone to failure. Crews sent into combat in these machines find themselves inside vehicles that are completely unsuited to the threat environment. As a result, many of these tanks are destroyed or abandoned soon after reaching the front line. The draining of reserve stocks has led to a steep and irreversible decline in the overall quality of Russia's armored forces. The second route for maintaining tank numbers, new production and modernization, is equally troubled. Russian state media frequently tout rising output at plants such as Uralvagonzavod, but the reality inside these factories is grim. Western sanctions have severely damaged the military-industrial complex by blocking access to crucial components that Russia once imported. Modern tanks require high-quality thermal imaging systems, which in the past came from companies like Thales in France, precision machining tools for gun barrels sourced from Germany or Switzerland, and advanced microchips for fire control computers and other onboard electronics. Cut off from these supplies, Russia has been forced to turn to older stock, lower-grade domestic substitutes or components acquired covertly through complex networks in countries such as China and Kazakhstan. Production of top-tier models like the T-90M has slowed dramatically, and many of the tanks that do roll out of the factory gates are built with downgraded electronics or non-military-grade chips scavenged from civilian devices. The convoluted supply chains and the costs associated with smuggling or middlemen mean that Russia often pays more for components that perform worse than the parts they once bought openly from the West. This reliance on dual-use technology not designed for frontline combat introduces massive operational risks. Systems fail unexpectedly, targeting becomes less accurate, and night fighting capability is degraded. At the same time, there is little real innovation coming from the Russian military-industrial base. Even if the number of tanks being produced or rebuilt edges upward, the quality and survivability of each vehicle continues to decline. The net result is a tank fleet defined by a flawed Cold War design philosophy and deprived of the modern technologies needed to survive in a 21st century battle space. This reliance on dual-use technology not designed for frontline combat introduces massive operational risks. Systems fail unexpectedly, targeting becomes less accurate, and night fighting capability is degraded. At the same time, there is little real innovation coming from the Russian military-industrial base. Even if the number of tanks being produced or rebuilt edges upward, the quality and survivability of each vehicle continues to decline. The net result is a tank fleet defined by a flawed Cold War design philosophy and deprived of the modern technologies needed to survive in a 21st century battle space. Strategically, the failure of Russia's offensive is now inseparable from the failure of its primary weapon system. The Russian tank is no longer an armored spearhead. It has become a mobile funeral pyre, its inherent design flaws ruthlessly exploited by the combination of high-end anti-tank systems and swarms of low-cost drones. Moscow's inability to reform its industrial base, update its doctrine, and field tanks that can survive in this environment has turned the war into a slow-motion demolition of its once feared armored forces. The collapse of the T-Series family is therefore not a temporary setback, but a lasting symbol of Russia's diminishing status as a modern military power. It marks the end of the Cold War-era model of mass-produced, expendable armor as a decisive instrument of Russian policy. The obsolescence of the tank as Moscow's primary breakthrough weapon is now effectively priced into the war. And if you want to understand how this tactical revolution unfolded in practice, you need to see the firepower that made it possible. To dive deeper into the success of the Javelin system and the broader shift in military technology that is dismantling Russia's armored doctrine, watch our dedicated video on how this channel is tracking the collapse of Russia's tank forces in real time.